All right, also rational functions. And when you see rational, they mainly mean fractional. So we're looking at fractional functions again. Um, all right, so first they do a couple domain questions. So they want us to determine the domain of the function. So these are just like we did in module one. Only difference is now they want us to write the answers in interval notation, okay? So for my first one, they're giving me f of x equals x squared over 6 minus x. So remember, the domain, all I'm worried about is the denominator of a fraction. And we said that the bottom of this fraction could not equal 0. So to solve it, we actually set it equal to 0 and try to find the value of x, okay? So here, to solve that, I would subtract 6. Well, that cancels, and I get a negative x equals a negative 6. And then we need to make the x positive, so divide both sides by negative 1. So this is positive x, and then negative divided by negative makes that a positive 6. So we need to kick out 6 from our domain. So this is when we didn't do any when I gave you all these instructions, but we start with negative infinity. And then since we cannot equal 6, we're going to union around that 6. So put the 6, curvy parentheses means it does not include the 6. And then you union from 6 to infinity. So to kick a number out of our domain, we union around it. We can almost equal 6 from the negative side, and then from the positive side, we go just after 6, because remember, the curvy parentheses means you do not include the 6 in the domain. And then it's good for all numbers towards positive infinity. So we kick out numbers using the union, okay? We just sort of union right around that number. So this one had one number to kick out. This next example, we're going to have two numbers to kick out. So they're giving me f of x equals 3 over x squared plus 2x minus 24. All right, so I'm going to set that denominator equal to 0. So the trick on this one is to factor this one. Since it's quadratic, you can either factor it or use the quadratic formula. But y'all, these aren't bad to factor if you just get used to them signs here. So x squared would be an x and an x in both parentheses. Now I'm looking at this last sign. This last sign is negative. Anytime the last sign is negative, one factor will be positive, one factor will be negative. Because remember, positive times a negative equals a negative, okay? Now, since the last one is negative, I'm looking for factors of 24 that subtract to get me a 2. So y'all, 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6. The factors that'll subtract and give me 2 are 4 and 6. Now, when you have unlike signs, the larger number has the same sign as the middle number. So the 6 is going to be positive like the 2, and then the 4 would be my negative. All right, so 6 minus 4 equals 2. 6 times negative 4 equals negative 24. At this point, set both factors equal to 0 and solve them for the x's. So on the first one, I'll just subtract 6 from both sides. I get 6, x equals negative 6. On the second one, I would add 4 to both sides and get x equals a positive 4. So when we write the interval, we got to go in order from left to right. So we're going to kick out the negative number first and then the positive number. So we're going to start at negative infinity until we get to negative 6. We're going to union around that negative 6. From negative 6, all the numbers can be included until I hit 4. So we need to kick out 4. So we're going to union right around that 4. And then there's no other numbers I can kick out. So I'm good as I head off towards positive infinity. On the domains, they're all going to start at negative infinity and end at positive infinity. Okay, negative infinity, positive. All you're doing is unioning around any numbers that you got to kick out. All right, y'all. So let's get a definition here. A vertical asymptote. All right, so since we're dealing with rational functions, we got to talk about vertical asymptotes. So these vertical asymptotes, they're like imaginary vertical lines. So this is an imaginary vertical line that occurs where a graph is undefined. Okay, so it's like an imaginary vertical line that occurs where a graph is undefined. The graph cannot cross over the vertical line. No, because the graph is undefined at that point, so it cannot go over that vertical asymptote sitting there, okay? Now, they come in the form of an equation. So they come in the form of an equation. Since it's a vertical line, the equation is going to be x equals some number. Okay? Now, here's the thing about a vertical asymptote. A vertical asymptote can be canceled by a factor on the top. And if that happens, it creates a hole in the graph. Instead of a vertical asymptote, it just makes a hole in the graph, okay? So, a vertical asymptote can be canceled by the same factor on top. When this happens, so when this happens, it creates a hole in the graph. So y'all, what I'm talking about here, so say here's me a graph. So say my graph was undefined at this point and it made a vertical asymptote there. Remember, this is an imaginary line. You're not going to see this in your calculator when you graph it because this is an imaginary line. But on an asymptote, what will happen? Your graph will come along, and when it approaches this vertical asymptote, one side of the graph is going to head towards positive infinity. The other one will come in from negative infinity and go up. So the asymptote is this dotted line. The graph won't cross it. What will happen is it'll just keep shooting up and up and up towards positive infinity, but it cannot cross over this, okay? Same thing on this side. This side will keep going down towards negative infinity, but it never crosses over that imaginary line. Now, what happens when a factor on top matches the factor on the bottom, it sort of cancels that asymptote. And what might happen is you might have a graph coming and it creates a hole and then the graph keeps going. This hole is undefined, so whatever value made that undefined, it'll make a hole at that point of the graph, okay? Now, on the calculator, you're not going to see that hole because of the way the calculators are pixeled and stuff. Um, but yeah, that's what it's actually doing when it's undefined and the factor on top matches one of them factors on the bottom. And we have a problem later where you'll see that, okay? But y'all, vertical asymptotes, like I said, they're mainly just imaginary lines here. Now, to find a vertical asymptote, so to find a vertical asymptote, since they occur where the graph is undefined, you're going to find the vertical asymptote the same way you find the domain. So to find a vertical asymptote, we set the denominator equal to 0 and solve for the variable. Now remember, always check the numerator for any factors that could cancel the vertical asymptote. Okay, so you always want to check the top just to look at it real quick and see if it's possible that it might have a factor that matches your denominator. If it does, it cancels out that vertical asymptote and it's going to create that hole, okay? All right, so we'll do some problems with vertical asymptotes and then they'll get into horizontal asymptotes, okay? So y'all, these examples are going to say, find the vertical asymptotes. And that could be more than one, so that's going to be an S, okay? So might be an asymptote, might be several asymptotes. So y'all, my first one, f of x equals 1 over x minus 2 squared. So there's no factors on top on this and other than 1, so I'm not going to get anything to cancel on this one, okay? So what I'm going to do, you're going to find it just like you did the domain. We're going to set the denominator equal to 0. X minus 2 squared means x minus 2 times x minus 2. So you got a repeating factor. So since we got a repeating factor, I don't have to solve both of those because they're both going to give me the same answer. So I'm just going to continue on by setting one of the factors equal to 0. And remember, since this is an even exponent, this factor would sort of come down and be tangent to the x-axis. Um, so y'all solve that. All we got to do is what? Add the 2 to both sides. And I get x equals 2. So remember, the vertical asymptote has to come in the form of an equation. So in MATLAB, you would actually put x equals 2 as your answer. So if you was to graph this over here at 2, and I'll show you a graph real quick so that y'all can see what that asymptote's doing. So y'all let me go to y equals, I'm going to do alpha y equals enter to get the fraction. On top it had a 1. On the bottom it had an x minus 2, and that was squared. Now remember, at positive 2 I had an asymptote. So let me graph it. And see, this one, both sides are going up. But y'all, at positive 2, if you were to draw you a imaginary dotted line, you would see that it does not cross over that imaginary dotted line. So on this one, both sides are sort of heading up towards positive infinity, but they never cross it, okay? Oh, and let me show you what happens. When you look at the table, second graph, when you go to x value of 2, you get an error at the x value of 2. And you get an error because it's undefined, okay? So yeah, if you used to graph these, you would see that they cannot cross over wherever you are getting these asymptotes. All right, y'all, the next one. F of x equals x minus 4 over x squared plus 3x. So what they're going to do now, they're just going to give you different types of equations on the bottom just to see how you can factor and solve them, okay? So I'm going to set x squared plus 3x equal to 0. So y'all, this is quadratic, but look at it. You got the x squared term and you got the x term. What we're missing is the number. So when you got the x squared term and the x term, the easiest way to solve this is to factor out the greatest common factor. So x squared and 3x both have an x. You would factor that out. Inside the parentheses, you would have the x plus 3 in all of this equal to 0. So remember, anytime you got an x in both of your terms, factor that x out, and then we'll solve this. So remember, anytime you factored out an x, it always equaled 0. And then I'll set the x plus 3 equal to 0. So on this one, I would what? Minus 3 from both sides and get x equals a negative 3. So exponent of 2, you have to exclude 2 numbers. So look here, I'm looking on top. So my factors were x and x plus 3. The only factor on top is the x minus 4. So it will not cancel neither one of those. So I'm going to keep both of these asymptotes. So in MATLAB, I want the x equals 0, comma, x equals negative 3. Okay, y'all, so they're not too bad. You just got to figure out, how do I have to solve for these variables? So this one had an x plus 1. over 4 minus x. So, since I only got an x down here, there's only one number I'm worried about. So I'm going to set that bottom equal to 0. All right, y'all. So on this one, we need to move that 4 over. So we'll subtract it. So that gives me a negative x equals negative 4. And y'all, let's divide both sides by negative 1 to make the x positive. So that gives me a positive x. And then negative by negative makes that a positive 4. Okay, so no way to factor on top is going to cancel with this factor on bottom. So x equals 4 would be my vertical asymptote. So y'all, like I said, it's just going through there and figuring out how to solve that denominator and then doing a quick check and seeing if anything on top will cancel it, okay? All right, y'all, questions on these yet? Because I got a few more. So let's try this. And f of x equals negative 2 over x plus 2, x minus 5. All righty, so no variable on top at all, so I ain't got to worry about anything canceling on this. Now, this one's already sort of factored for us, so all we got to do is set that all equal to 0. So since this one's factored, it's saving us a step. All we got to do is set both the factors equal to 0 and solve each of them. So we like it when they've already got them factored, okay? All right, y'all, so this one I would what? Subtract 2 from both sides. I'm going to get x equals a negative 2. On this one, since that's being subtracted, I would add 5 and get x is a positive 5. So on MATLAB, I would choose the one that matches my asymptotes, okay? A lot of these in MATLAB are sort of like multiple choice. All right, y'all, let's try this one. So this one, I got an x squared plus 2x minus 15 on top. On bottom, I got an x squared minus 4x minus 21. So y'all, this one, it's possible. I'm going to have to factor the top to make sure it don't cancel with any of my factors on the bottom, okay? So we will have to check the top on this one. So first, let's worry about the bottom. Set x squared minus 4x minus 21. Set that equal to 0. Let's find these two values we're worried about first. All right, y'all, x squared is an x and an x. Remember, the last number is negative, so one factor is positive, one's negative. Factors of 21, that'll subtract and give me 4. So let's say 21 is 1 times 21. That don't work. Oh, y'all, 7 times 3 equals 21. 7 minus 3 equals 4. So the larger number 7 has to be negative like the middle number. And then the 3 would be my positive. So at that point, I'm going to solve both of these. So y'all, the first one, we would subtract 3 from both sides. The second one, I would add 7 to both sides. So these are my two possible asymptotes. But y'all, we need to factor the top and make sure none of them factors matches these two factors here, okay? So we're just going to do a quick factor on the top. X squared is an X and an X. Last number is negative, so one of these will be positive, one of these will be negative. Y'all, can you find me factors of 15 that'll subtract and give me a 2? Okay, y'all got 5, and negative 3. Good job, because the 5's got to be positive like the middle, and then negative 3. All right, y'all, so this top is sort of factored, and I'm just going to check. This was an x plus 3. That's an x minus 3. So they're not going to cancel. And then that had a 5 on top, and my other one was a 7. So those aren't canceling. So in MATLAB, we would want x equals negative 3, comma, x equals 7. And y'all, that's all you got to do real quick is check it and make sure none of those factors cancel, okay? And y'all, so the next one will have stuff that cancels for us. So let me get my camera moved back up. All right, y'all, same stuff. This one is giving me g of x equals x cubed over 5x cubed minus a x squared minus 6x. Alrighty, so remember, y'all, this x cubed on top is like an x times an x times an x, okay? So I'm going to play with the bottom. I'm going to set 5x cubed minus x squared minus 6x equal to 0. So the first thing, you got an x, and an x. So on this one, we do have a greatest common factor of an x. So we need to divide out one of these x's and then get in here. That'll give me a 5x squared right here. Minus an x and then minus 6. All equal to 0. So I'm going to finish factoring, but I want y'all to see something. One of the factors is a single x. On top, I got single x's. I got an x times x times x. So one of these x's on top is going to cancel out this vertical asymptote. So you can sort of cancel this one out because it matches a factor on top, okay? So cancel the factor x since the top contains the same factor. So now what you would do, all that's left is going to be the 5x squared minus x minus 6 equal to 0. So this we got to solve. So y'all, I'm going to use my quadratic formula real quick. A is 5, B is negative 1, C is negative 6. So y'all remember the quadratic formula was negative B. Well, B is a negative 1 plus or minus square root B squared would be negative 1 squared minus 4 times A, which is 5, C, which is negative 6. All of that's over 2 times A, which is 5. All right, also negative times negative makes that a positive 1, plus or minus. So let's see what we get under here. Negative 1 squared is a positive 1. And y'all, all this side's being multiplied. So let's see what we get. Negative 4 times 5 is negative 20. Negative 20 times negative 6 is a positive 120. All over 2 times 5 is 10. All right, y'all, so let's add under here. So 1 and 120 give me 121 all over 10. So y'all, to go further, I need to know the square root of 121. So square root of 121 is 11, all of that over 10. So now we're going to get the first answer and then our second answer. So remember on the quadratic formula, the first time you add, so you're going to do 1 plus 11 over 10, which gives me 12 over 10. And y'all, if I reduce this fraction, it reduces to a 6/5. So one answer is 6/5. And then the second answer, I would do 1 minus 11 over 10. So y'all, that'd give me a negative 10 over 10, which is a negative 1. So my vertical asymptotes will be x equals 6/5, x equals negative 1. So y'all, that's where that quadratic formula comes in. When you got difficult things to factor, knock it out with that quad real quick, okay? Alrighty, y'all. So now let's get into horizontal asymptote. All right, so horizontal asymptote, it's like an imaginary horizontal line that the graph tries to approach as the x's head out towards infinity. Actually, it'd be what, negative and positive infinity on those, okay? So, um, these come in the form of y equals some number. Okay, since they're horizontal, they're going to be y lines, okay? Now, the graph don't really cross them. It tries to get to them over time, okay? So over time, it'll get closer and closer in value to these horizontal asymptotes. So let me show you. Um, so you can have a graph coming down and it just tries to get closer and closer to the x-axis as it heads towards infinity. So these are your horizontals, okay? And then the verticals were where it was undefined. Now, there's three cases to determine the horizontal asymptote. And what we do is we compare the degree of the numerator to the degree of the denominator. So we're looking at the biggest exponents of each, okay? If the top contains a higher degree than the bottom, then, so if the top has got a higher exponent, it's going to grow a lot quicker than the bottom. When that happens, there is no horizontal asymptote. Because y'all, the top's headed off towards infinity a lot faster than that bottom. So the top is always going to make the problem getting larger and larger. So it won't reach any number. It's going to head off towards infinity. So the top greater than the bottom, no asymptote. So if the top contains a lower degree than the bottom, then, so now the bottom exponent is bigger than the top. If that's the case, then it'll be y equals 0. Okay? Alrighty. So top higher degree, no asymptote. Bottom a higher degree, it equals y equals 0. And y'all, the third case, if the top equals the bottom, so if the top degree equals the bottom degree, then it equals y over a. So y will equal a over b, where a is lead coefficient on top, and b is the lead coefficient on bottom. Okay, so lead coefficients are the numbers in front of the variables with those highest exponents, okay? So top heavy, no asymptote. So this is top heavy. This one's bottom heavy. When it's bottom heavy, it's going to be y equals 0. And when they're equal, then you got to look at the numbers in the front, okay? All right, y'all, so let's see what these examples got. They want to determine the horizontal asymptotes. Fx equals 4x squared plus 5 over 5x squared minus 3. Alrighty. These ones are matching. These ones are equal. The top degree is a 2. Bottom degree is a 2. So these degrees equal. So the degrees equal. So we said if the degrees equal, then we're looking at y equals a over b. Well, remember, a is the lead coefficient on top, b is the lead coefficient on bottom. So y'all, the lead coefficient on top is a 4 over the lead coefficient on bottom is a 5th. So this one, as it's headed out towards infinity, is going to try to reach that value 4 over 5. Close to 1, but not quite there, okay? And that's what it's going to do as it heads towards infinity. So 2 and 2 are equal, okay? So let's try this one. X squared minus 8 over 3x to the 4th plus 2. So y'all, any guesses on this one? All right, so let's see. I got an exponent 2 on top. Oh, y'all are rolling in now, so my internet must have been just a little slow. So this one was sort of like bottom heavy, right? So the bottom was greater than the top on that one. And y'all are perfect. We said when the bottom was greater than the top, it automatically equals y equals 0. Oh, y'all, so let me try one like this one. Oh, this one's got an x to the 3rd minus 5x squared plus x minus 3. All of that's over x squared minus 18. So y'all, what do y'all think on that one? Hey y'all, because the bottom is less than the top, and anytime it was top heavy, we said there was no horizontal asymptote. Good job. All right, so on the horizontal, you just look real quick at them degrees, and that tells you pretty much about your horizontal asymptote, okay? All right, y'all. So the last two problems in this section deal with finding certain things and then picking a graph, okay? Um, so let me write down what they want. So they want the domain. So let's see. Any asymptotes, but they don't make you list them, I don't think. So asymptotes, x and y intercepts. Then graph. Okay. So y'all, let's start out with f of x equals 4x plus 2 over x. Okay, and I'll show you how to find anything as we're going. For the domain, we know how to do the domain. The domain, we're going to set the bottom equal to 0. Well, y'all, that's all you can do to that. Set x equal to 0. Well, you don't have nothing to do to solve that. So the only number that x cannot be in the denominator is a 0. So interval notation would be negative infinity, union around 0, remember, because we're kicking it out. And then from 0 to positive infinity. So then they're looking at x-intercepts. So for the x-intercept, the way you find the x-intercept is by setting the numerator equal to 0. So you're going to set the numerator equal to 0. So doing that, I got 4x plus 2 equals 0. So y'all, let's solve this real quick. Subtract 2. Y'all are going to get your 4x equals negative 2. And then divide both sides by 4. So that cancels, giving me x equals a negative. Y'all, I'm just going to reduce that. 2 fourths reduces to a negative 1/2. Now, since it's an x-intercept, we got to put it in as an ordered pair. So negative 1/2 for the x, 0 for the y, okay? Alrighty, next was the y-intercept. To find the y-intercept, you find f of 0. So f of 0 is going to equal 4 times 0 plus 2 over 0. So y'all, can we even work that? No, because we got a 0 in the denominator. So this is undefined. So that means there is no y-intercept. Okay, so you can't divide by 0, so there's no y-intercept, because we said right here, we're kicking that 0 out anyway, right? Now, y'all, let me see. So on this one, you'll find the x-intercept, y-intercept. Um, then they just show you the graph. Now, I know this was going to have a vertical asymptote at 0. So if you just sort of hand scratching it, at 0 here, my graph cannot cross, so I would technically, I've got a vertical asymptote right there. Okay, so the graph cannot cross over that line. Now, I know my x-intercept, so if this was going by 1, say, -1, -2, -3, -4, -5, I know my x-intercept was over here at -1/2 and 0, which will be about right there. Okay, we didn't have a y-intercept. Let's see. The degree on top is the same as the degree on bottom. So since the degrees are the same, my horizontal asymptote would be y equals 4 over 1, which is basically 4. So if I was going up, say that was 5. So up here at 4, eventually as it heads out towards infinity, it's going to try to get to that line right there, okay? So we might need to plot a point or two to see which direction is this graph going. So if I put a 1 in here, 4 times 1 is 4, plus 2 is 6, 6 over 1 is 6. So when x is 1, right here's 1, my y value is up here at 6. All right, I might use another number. Try 2. 4 times 2 is 8, plus 2 is 10, divided by 2. 10 divided by 2 would be 5. So at 2, this is trying to get down here at 5. So I can sort of see what's happening here. This side is coming in from infinity. It's coming down, and it's going to try to eventually get closer to that 4 on that side. Now this side, since that x-intercept is down here, this side is coming up, and it's going to try to get to the 4 as it heads out that way. So y'all, let's go look on our graph and see what we get on our calculator. So y equals, I'm going to clear that out. I'm going to hit alpha y equals enter for my fraction. So on top I had 4x plus 2. On the bottom, I had an x. All right, y'all, so I just want to see the graph. And there you go. This side's coming down, crosses over at that -1/2. And then the right side's coming in. And both sides are trying to get to that 4 on the x-axis. All right, there'll be one more of those for y'all to play with. And then just look at your picture to pick out one of the 4, okay? All right, y'all, so that's how you would find that stuff. So let me go back. All right, so that was 8.5. So y'all, I'm going to pause this so we can do our break. All right, y'all, so 8.6 deals with polynomial inequalities. So inequalities, remember, these are going to deal with greater than, less than type stuff. So I'm going to write the steps to solving the inequalities. And y'all, I'll show you solving them by hand and how to solve them by graphing, okay? All right, so the first thing we got to do is solve the polynomial. And we'll solve it by setting it equal to 0, okay? All righty. So I'm going to solve the polynomial. It's going to give me 2 answers. So I'm going to create a number line using those 2 solutions. All right, so y'all, when I do that, I'm going to have me a little number line here. I'll have my first solution and my second solution. So I'm just going to create a number line using my solutions. Then I'm going to use a test point to determine if a section is true or false. So I get a test point, and I usually use 0 for my test point, but you test it by putting it back into the original polynomial and seeing whether it's true or false, okay? If it's true, shade that section. Now, there's two cases that can happen. If it's true in the center section where you test it, then that's the only section that'll get shaded is the center section. Now, if you tested it, if it's false in the center, then that means it's going to be true on both of the ends. So it's either true in the center or it's going to be true on the ends here, okay? It's going to be one of these two cases when you got two numbers. So once you've figured out where to shade it, you're going to write the answer in interval notation. Now, around the numbers, if it is greater than or less than, we're going to use parentheses around the number. If it's greater than or equal or less than or equal, we're going to use brackets around our numbers. Okay? Now, infinity, if you got infinity, that's always curvy parentheses, okay? But the numbers depend on the inequality to know whether I'm using parentheses or brackets. Now, there's two other things that'll happen. If we have repeating solutions, so you get x plus 2, which both gave you -2. If you have repeating solutions, then that is the only number you exclude. Okay? So that's the only number excluded. And the second thing is, if it's not factorable, so if you cannot factor the polynomial, then it is a no solution. And in MATLAB, no solution is a 0 with a line through it. This means no solution. So when you click the answer blank on that little roll of tools, you'll see that circle with that line in it, okay? All right, so the second way I'll show you is by graphing, and I'll show you when we play with one of these, how to look at the graph, okay? So y'all, these are just going to say, solve the following inequality. Okay? So y'all, my first one, x minus 3 times x plus 1 is less than 0. So this one's already sort of factored. So what I'm going to do is take each of the factors and set them equal to 0. So I know this is less than, but we're going to use equals when we solve it. And then we'll play with that when we sort of write our intervals, okay? So for this one, add 3. You get x equals 3. Here you would subtract 1 and get x equals a -1. So I said you're going to set up a number line. So I'm going to go in order. So -1 would be here, and then 3 would be here. So I always test 0, so I got to figure out where 0 is on my number line. And y'all, 0 is going to be in between -1 and 3. So that's where 0 is, in between there. So I'm going to test 0. So to test 0, I'm going to put a 0 in for these x's. So I got 0 minus 3, 0 plus 1 has to be less than 0. So we need to see if this is true or false. So y'all, 0 minus 3 is the -3 times 0 plus 1 is 1. That's got to be less than 0. So y'all, that's going to give me what? A -3 on the left side, less than 0. So you got to figure out, is that true or false? Well, y'all, that is definitely true. So since -3 is less than 0 is true, you would come in on your number line and shade that section because it was true. Okay? Now, we're going to write this in interval notation. It's going to go from -1 to 3. Question is, would I use parentheses or brackets around my number? Well, y'all, this is less than, so less than uses parentheses. So my interval will be parentheses, -1 to a +3, close parentheses. Okay? Now, let me show you the graph of this, and I'll show you another way that you can find this answer. So y'all, I'm going to go to my calculator. I'm going to go to y equals and clear this off. So I had parentheses, x minus 3, close parentheses, and in parentheses, x plus 1. And close. Now remember, since we're setting them equal to 0, 0 is the x-axis. And this is less than. So I'm looking for what part of my graph is going to be less than the x-axis. So y'all, when I hit graph, so less than will be the part of the parabola that's under the x-axis. So if you look at it on the left side, it starts going under the x-axis at -1. And then it's under the x-axis until it gets to 3 on the x-axis. Okay? So it's under from -1 to 3, which was what we got on our interval. All right, y'all, next one. X squared minus 15x plus 44 has to be greater than 0. So this one we're going to factor. And when I'm solving it, I'm just going to set it equal to 0. So x squared is an x and an x. Now y'all look here. This last number is positive. Anytime the last number is positive, both of these factors will have the same sign as the middle. So a negative and a negative. Because a negative plus a negative equals a negative times a negative equals a positive. All right, y'all, I need factors of 44 that'll add to give me 15. So 1 and 44, 2 and 22. What's next? 4 times 11. And I think that's it. So the ones that'll give me 15 are going to be 4 and 11. All right, so now we're at this point. So let's set both these equal to 0 and solve. So y'all, the first one, I'm going to add 4 to both sides. I get x is a positive 4. This one, I'm going to add 11 to both sides and get x is a positive 11. So for this one, my number line, let's see, I'm going to hit 4 first and then 11. Now, what I need to do is I'm going to find me a test number. I'm still going to test 0. 0 is going to be in the first section. 0 is less than 4, so it's in this first section, okay? So I'm going to test my 0 now. So that's going to give me 0 squared minus 15 times 0 plus 44 has to be greater than 0. Well, y'all, 0 squared is 0. 15 times 0 is 0. So you got 0, 0, and 44, which equals 44 greater than 0. So that is definitely true. So since that's true, I'm going to shade the section that 0 was in. Now, y'all, here's the thing. Since these are parabola-shaped graphs, anytime you shade the first section, you got to shade the last section. Those two always go together. It's either the middle or the two ends, okay? Now, since you're doing the end here, this one's going to start at negative infinity until we hit 4. So at 4, I need to figure out, do I want parentheses or brackets? Well, y'all, that's a greater than. There's no equals under it. So we're going to use parentheses. All right. Then we're going to union and start. We don't want nothing in between. We can't go 4 to 11 because that's false. We got to start where the second shading starts, and that's at 11. So from 11, it's shaded as we head towards positive infinity. Hey, y'all, that's a trick on these. Now, since this was greater than, when you graph it, this side and this side will both be above the x-axis, and then from 4 to 11 would be below it because it's less than. But we wanted the greater than, so that's going to be the two parts that are above the x-axis. All right, y'all, look at this one. X squared minus 4x minus 19 is greater than or equal to x minus 5. So y'all, on this one, I need a 0 on this right side. So I'm going to move the x over by subtracting it. So I'm going to subtract the x from both sides. And I'm going to move this negative 5 over by adding 5. So you get your x squared. Negative 4, negative 1 is negative 5x. Negative 19, positive 5 is a negative 14. That's got to be greater than or equal to 0. Now at this point, this is where when I test it, I'm going to put my zeros into this one and see if this is true, okay? All right, so let me factor this to get my two numbers. X squared is an X and an X. Y'all, this time, the last number is negative. So you're going to have unlike signs. And I'm finding factors of 14 that'll subtract and give me 5. So 14 is 1 and 14, 2 and 7. The numbers that'll subtract and give me 5 are 2 and 7. Now remember, when you got unlike signs, the larger number has the same sign as the middle. So the 7 is negative, 2 is positive. All right, y'all solve both of these by setting them equal to 0 and get our two numbers. So first one, I will subtract 2. I'm going to get x is a negative 2. The second one, you would add 7 and get x is a positive 7. So your number line on that one has a negative 2 here and then a 7 over here. So once again, I'm going to see zeros in between those two. So I'm going to test my 0 again. Now, y'all can pick any number you want to test, but y'all, zeros are the easiest thing to put in here and check. And I'm going to use this equation where it's got the 0, okay? So x squared would be 0 squared minus 5 times 0 minus 14. That has to be greater than or equal to 0. Well, y'all, that's 0. That's 0. So I basically get negative 14 greater than or equal to 0. True or false? Well, y'all, that is definitely false. Negative numbers cannot be greater than 0. So that is false. So since that's false, I do not shade the section where the 0 was located. That means I got to shade the outer sections. So true, you shade it. False, you got to shade the outer sections. Which means this is going to start out like negative infinity until we get to negative 2. Now y'all look here. That one has equals in it. So since that has equals, we got to use a bracket. And then union from the second number, which is 7 to positive infinity. So y'all just be careful whether you're using the brackets or parentheses on these. It's based on whether you got the equals or not, okay? Alrighty, y'all, continuing on. Same thing, we're going to solve the inequality. All right, so this one has x squared greater than 81. So this one, since you don't have an x term, you just got the x squared term and the number. What I would do to that would be take square roots real quick and solve it. So to take square roots of both sides. So the square root of x squared is x. Square root of 81 is a plus or minus 9. So when you got an x squared in the number, that's the easiest thing to do is just get the number on the right side, take the square roots. So come in now. We got a negative 9 on one side and a positive 9 on the other. So if I'm going to test 0, zero's in between a negative 9 and a positive 9. So to test zero, I got 0 squared has to be greater than 81. Well, 0 squared is 0, so 0 greater than 81 is false. So since that's false for 0 in the middle, I do not shade the middle. I come out and I shade the ends. Okay, y'all, so any number you can pick here. So say you picked a number like -10. It was true here, so you would shade this and automatically the other side. Like I said, it don't matter what number you're choosing. To me, 0 is just the easiest. Okay? All right, y'all, so this one's starting at -infinity up to -9. There's no equals, so you use curvy parentheses. Union that. On the right side, you start at 9 and you head off towards positive infinity. Y'all, the reason this is a parenthesis instead of a bracket, because if you put a 9 over here, 9 times 9 is 81. Well, 81 is not greater than 81. 81 equals 81. So since there's no equals here, that's why we're not using brackets, okay? All right, y'all, let's see what you do here. 16 minus x squared has to be less than or equal to 0. All right, so first thing I would do, since I got an x squared and a number, I would move that number over. So that cancels. That's going to give me a negative x squared less than or equal to a -16. I need my x squared positive, so I'm going to divide by -1. And y'all remember this, I'm dividing an inequality by a negative number. So what are you going to do? Remember, if you divide the inequality by a negative number being your right, you're going to flip that sign, and that's now going to be a greater than or equal. So you got x squared is now greater than or equal to a positive 16. So this is the one I'm going to test right here where I got everything solved. Now, to finish that out, I'm going to take square roots of both sides. Square root of x squared is x. That's going to equal a plus or minus square root of 16, which is 4. All right, so there's my two numbers, -4 and 4, and I'm going to test that equation right there. Now, y'all, so here's -4, here's +4. 0, once again, is right in between. So I'm going to test 0. So I got 0 squared has to be greater than or equal to 16. Well, 0 greater than 16, that is false. So I'm not going to shade where the 0 was located. Since I'm not shading where 0 was located, I'm going to shade the outer edges. Okay? So that means this interval started at -infinity again until I hit -4. There's an equals here, so we want to use a bracket and then union on the right side from 4 to a positive infinity. Alrighty, y'all, so that's the trick on these, okay? Hey, y'all, let me see what they're doing on number 6. 6x minus 9 minus x squared is less than 0. So y'all, let me get them in order. I'm going to throw that negative x squared up front, plus my 6x, minus my 9. All that has to be less than 0. Now, I don't want to factor this with this negative here. Anytime the x squared is negative, you're going to divide everybody by -1. And you got to do every single term when you're dividing, okay? But y'all, that negative divided by negative is going to make that a positive x squared. That's going to make that a negative 6x. Negative divided by negative is going to make that a positive 9. I'm dividing by negative, so we're going to flip the sign, and this becomes greater than 0. All right, let's factor this and solve it. So when I test it, I'll put my 0 here. All right, x squared is an x and an x. The last sign is positive, so both of these will be negative like the middle. So anytime the last sign is positive, you got to have like signs down here, okay? All right, factors of 9, that'll give me 6. We all 9 is 1 and 9, 3 and 3. So 3 and 3 give me 6. Oh, y'all, look at that. I got repeating factors. So I'm just going to solve one of these by adding 3, and I get x equaled 3. So remember, when I had repeating factors, I said the only number we exclude from the domain would be that 3. Okay? So that's the only number excluded. So since that's the only number excluded, your domain would go from -infinity up to 3. You're kicking out 3, so you're going to union around that 3 until you hit positive infinity. Right, y'all? So on number 6, repeating factor, only kick out that one number from your domain. All right, y'all, we got one more and then we're done. So this one has x squared plus 15 is less than 5x. So y'all, you need a 0 on this right side. So you're going to move the 5x by subtracting. So let's see, that'll go about right there, right? So this side, no like terms. So I'm just going to put them in order. X squared, then my minus 5x, then my plus 15, all has to be less than 0. All right, y'all, then we're going to try to factor this. X squared is x and an x. The last sign is positive. So since that's positive, both of these will be negative like the middle. All right, y'all, I need factors of 15. So that'll be 1 and 15, 3 and 5. Since that's positive, I need factors of 15 that'll add and give me 5. Well, y'all, those don't give me 5. These two, if I add, don't give me 5. So there's no numbers that I can put in here that'll satisfy this polynomial. So this one does not factor. So since it does not factor, this is a no solution. And y'all, let me show you what happens on that one. When it's a no solution and we were less than 0, so we're looking for the graph that's under the x-axis. So this one I had an x squared minus 5x plus 15. So look at the graph. Remember, it's less than 0, so you're looking for the part of the graph under the x-axis. But y'all, when you graph it, everything is way above the x-axis there. So there's my little parabola sort of starting. So there's none of it less than the x-axis, so there's none of it less than 0. So that's why that one was a no solution, okay? See, oh, that's a trick on those. You can graph them to see if it's less than or greater than, or you above or below the x-axis. Remember, if it's got greater than or equals, less than or equals, use brackets on those intervals. If it's less than or greater than, use parentheses, okay? So the trick is just trying to get those things factored and getting those two numbers. Remember, if it had a repeating solution like my number 6, then that's the only number you kick out. Because that means it's coming down, touching the x-axis at that point, and then heading on. Alrighty, y'all. So do y'all have any questions today? All right, now I'm not seeing anything. So here's the thing. This finishes up Module 3 material. So when we come in Monday, we're going to review for test 3. And then Tuesday, we'll start our last module. Alrighty, y'all. So I don't see anything. So